Hi guys, welcome to NMAT. We have another interesting question here, and what we have here says how many discrete four-digit numbers can be formed from the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 without repetition. Alright, so how do we go about this? Now, to solve this question, first of all, we need to take note of two formulas, but we're going to use one. But let's just take note of two formulas where we have n combination r, and the formula will be n factorial over n minus r factorial, and then we also have n permutation r to be same as n factorial all over n minus r factorial. All right, so now we use combination when we are selecting, if it is a case where we have to select. Okay, so we use combination. Or if it is a case where we have to arrange, if we are arranging something, we use permutation. Okay, all right, so in this particular case, we need to arrange these numbers. Okay, so we arrange these numbers. So how many ways are we going to arrange these numbers in 4 digits now? All right, so we have 10 numbers here. So our n would be 10, and we have to place them in 4 places. So our r would then be 4. All right, so that's what we're going to do. But what we need to notice here is that we have 0. And if a number begins with 0, then that number, for instance, you have 0, 1, 2, 3. This number is not a 4-digit number because this would be the same as 1, 2, 3. And 1, 2, 3 is a 3-digit number, not a 4-digit number, okay, because it starts with 0. So that means that although the numbers of ways of arranging this would be, it's going to be 10 permutation 4. It's not all the numbers there are going to be 4 numbers, because any number that starts with 0 will definitely become a 3-digit number. So now we're going to do this. Now we're going to say, okay, how many numbers starts with 0? So if a number starts with 0, then we now have 3 places to arrange. We have 3 places to arrange these other numbers, and that would now be, if the number starts with 0, we now have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So n would therefore be 9, and our r would be the 3 places here that we have. And those 3 places, all right, so we now have this. So these are the number of ways, which means that 9 permutation 3 would be the number of numbers that start with 0. Okay, so this will be the number of numbers that starts with 0. And so we can then say that if we subtract that out from here, we now have the number of tens that are 4 digits. Okay, so what we're going to do is this minus 9 permutation 3. All right, so let's use this formula. So we're using this formula now. So in place of 10, we're going to say 10 factorial all over 10 minus 4 factorial minus, here we're going to say 9 factorial all over 9 minus 3 factorial. Okay, so what we have here would be a 10 factorial over a 6 factorial minus a 9 factorial over a 6 factorial. So on the denominator we have the same thing, so we can just say 10 factorial minus 9 factorial divided by 6 factorial. That's what this would give us. Okay, and 10 factorial minus 9 factorial, this would be the same thing as saying 10 factorial, 10 times 9 factorial, 10 times 9 factorial minus 9 factorial all over 6 factorial. Okay, so we have this. Now 9 factorial is common, so if we pull out 9 factorial, we now have 10 minus 1 all over 6 factorial. Now 10 minus 1 is 9. Okay, so therefore this 9 factorial will be the same as 9 times 8 times 7 times 6. We want to stop at 6, so we need to add factorial. And why we're stopping at 6 is because on the denominator we have 6 factorial. So we have 6 factorial on the denominator. 10 minus 1 gives us 9, still in the bracket there. So this can cancel this off, and then we can then say that this would be the same thing as 9 times 9, this 9 times this 9 times this 8 times 7. Okay? And the value for that would be 10 times 9 times 8 times 7, and that would be equal to 4, 5, 3, 6. So these are 4, 5, 3, 6 numbers that have 4-digit numbers. If we have to combine these or arrange these. Alright, so that's the answer to the question. I hope that this has been helpful to someone. Alright, so don't forget to subscribe and like. Thank you.